Kevin Kurtz, and I want to demonstrate magnetic levitation. This is a fun little party trick that you can get off the internet. It is a feedback control system. So this is a series of 2 permanent magnets and a piece of steel on top. And they're hovering and moving. You can spin them around. I'll show you what's underneath. There's a permanent magnet on this outside here that's creating a field that goes up and over. It's pushing against that. That'll let it hover. It'll actually push against it, but you'll never get it balanced. There's different air pressures, there's different gravitational fields here. This magnet's not perfectly symmetrical. There's no way I'm going to get that to hover on its own. But with this feedback control system, we can do that electronically. So there's a little smart device in there that's deciding how much current goes through these coils. So if you push current through a coil, we have this Lorentz force. We actually create this magnetic field in whatever direction we need. We call it the right-hand rule in physics. If you turn the current the other way, it'll go down. We can create north and south poles, and that'll let us push against this magnet. And it's changing that current really quickly based on feedback. So we've got these little lights connected that tell us what's happening and if it's symmetrical. If all my lights all the way around are blue, we're okay. If they're not, they start to go off and tell us which directions are causing the problem. And that's the little feedback controller deciding which directions need to fire more. It's also very hard to balance because it's trying to initiate itself while we're going. And if we crash those magnets together, they're very brittle, they will break. The paper here helps me not damage them when I do crash it. So it can actually hold a surprising amount of weight. And it can be pretty off balance. You'll see how far I can push that to the sides. Put that here. It's hard to balance because this thing isn't symmetrical either, but we can get a pretty good spin on it. And you can see there's a lot of cocking. It's really a smart control. It can change a lot of current to create a really large magnetic field that helps keep us balanced. Kind of like how a Segway stays up with his gyroscopic feedback. This is just a magnetic feedback. This notebook's surprisingly heavy, and yet it has no trouble at all holding it up. It has a very strong field, and all that happens is the closer it gets, the stronger the currents have to go to push it back up. So we're using slightly more power, but that's okay. It can handle it. So this is never going to perfectly balance with the permanent magnet solution, as we talked about. It's this feedback control loop pushing up on the magnet. So if I remove power, we're going to see it crash. Even though it's pretty balanced now, it's going to fall down to one side very quickly. Thanks for watching.